This problem is actually about me and when I'm going to be too old to actually see concerts because I'm too worried about my hearing. Only thing is I changed my name to Bob in this problem because I just like the name Bob for physics problems, as you guys probably know. So Bob loves Radiohead, just like I love Radiohead. The only problem is that Bob is losing his hearing, also, like me. If the sound level intensity is 110 decibels, 5 meters from the stage, where must Bob be so that he can actually be safe and won't lose his hearing? It's kind of cool that even at this level in this course, we can even approach a problem like this. How far Bob needs to be from the stage so that his hearing isn't damaged. Kind of makes you guys pretty powerful, or at least will be powerful once we solve this problem. So let's start with the sound level intensity equation. Beta equals 10 log, because it's base 10, we don't have to put the 10 for the base. I over I naught, where I naught is, do you guys remember? Do you remember? It is the threshold of hearing, which is 10 to the minus 12 watts per meter squared. Okay, so the question is, once again, is how far away from the stage do we need to be? But do we see an R anywhere in here? Do we see a distance? We don't. But we do know that I is actually equal to the power put out by the speaker, by the amplifiers of the band, divided by 4 pi times the distance that you are away from the speakers squared. So that tells us we probably want to substitute this in for I over here. So it'll instead look like beta equals 10 log P over 4 pi r squared over 10 to the minus 12. Okay? All right. Now, the next thing that I see when I look at this problem is I want to solve for R, how far Bob should be in order to feel safe, but I don't have the power of the speakers that he's going to be standing next to, right? I don't have the power of the speakers that the concert is projecting the sound out. So how can I find out how far I need to be if I don't know the power? You can't. But this is where you want to use the nice little information that the problem gives you. It says that the sound level intensity is 110 decibels when Bob is 5 meters away from the speaker. From that, we can go ahead and solve for P and use it to solve for how far he needs to be in order to actually be safe, at a safe decibel level. All right? Well, how do we do that? Really simple. It's just some high school math again. We take P over 4 pi 5 squared divided by 10 to the minus 12. Okay? And, you know, we want to divide both sides by 10, so we can get rid of that in front. And so we know that 11 must equal log base 10 of P over, well, 4 times 5 is 100. So that'll be over 100 pi divided by 10 to the minus 12. Okay? And you probably remember that there's this little rule that in order to get rid of a log, you could take the base of the log, put it to this exponent, and it's set equal to this, right? That would become 10 to the 11 equals P over 100 pi over 10 to the minus 12. You know, and then I would just go ahead and multiply both sides by 10 to the minus 12, solve for P. The power that I get is 314 watts. All right, so that's the power that these speakers are thrashing this music out at. Okay, now that we have this, watch what we can do. It's pretty cool. So I'm going to go ahead and erase the work that I've done, all this hard work. Okay, goodbye, 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 right? Now, instead, I can take my original equation, right, and I can put in this 314 for P, okay? And I have to decide, what is this decibel level that I'll consider safe, right? So I want to solve for R, at a decibel level that won't hurt Bob's ears too bad. And, I don't know. There's some debate about this, but I'm going to say that he'll probably be okay at around 80 decibels. Some people could argue that's still a little bit high, but I'm going to say it's rock and roll, baby. You got to just, deal with a little bit of loudness maybe. So I'm going to go with 80 decibels. As long as he's under 80 decibels, Bob's going to be okay. So let's put in 80 here. So I did 80 equals 10 log 314 over 4 pi r squared over 10 to the minus 12. And I want to find out that r now so that what Bob's hearing is 80 decibels or less. All right, well, I did the same thing again that I did last time. I divide by 10 on both sides. Okay, so it's going to be 8 equals log base 10, 314 over 4 pi r squared divided by 10 to the minus 12. You're going to do the same trick as you did before. I don't have a heck of a lot of room to do the algebra, but you're going to take 10 to the 8 equals this stuff. Do your algebra, practice your algebra, solve for r. In fact, I encourage you to solve for r and practice that on your own, because, the rest of science is going to be a bunch of algebra. I'm sorry, it's the way it works. So I get an r, when I solve this, do all this algebra, I get 500 meters. It's quite far away, but them some nosebleed seats. So unfortunately, Bob can't enjoy the concert the way that he would like. But future Scott is going to make the best of it. And so the point is, I demonstrated how we can use the sound level intensity equation in order to be able to actually solve for how far you need to be away from a concert to keep your ears safe. That's kind of cool. Before this lecture, you weren't able to do that. Now you can, and you're a little bit more powerful because of it.